Hi, and welcome to the world of computer networks. In this lecture, we will answer the question of what the Internet is. So let's start the session with the outcomes. Upon the end of this session, the learner will be able to understand what is the architecture of the Internet, what a protocol means, and what are network edge and network core concepts. The Internet is a computer network that interconnects billions of computing devices throughout the world. For example, we can find traditional desktop computers, Linux workstations, and servers that store and transmit information such as web pages and email messages. All of these devices are called hosts or end systems. End systems are connected by a network of packet switches like routers and switches through communication links. There are many types of communication links using different physical media, including coaxial cable, copper wire, optical fiber, and radio spectrum. Of course, different links can transmit data at different rates, with the transmission rate of a link measured in bytes per second. Finally, we can say that Internet is the connection of many networks managed by different organizations like Internet service providers or content providers. End systems access the Internet through Internet service providers. So many kinds of ISPs exist, such as telephone companies, corporate Wi-Fi access providers in public places like in airports and hotels. Each ISP is itself a network of packet switches and communication links. That's why we call Internet the network of networks. We cannot send and receive information without any control, so end systems, packet switches, or other pieces of the Internet run what we call protocols that control how to send and receive information within the Internet. The Transmission Control Protocol TCP and the Internet Protocol IP are two of the most important protocols on the Internet. Many other protocols exist, and we will talk about them in another lecture. Given the importance of protocols to the Internet, it is important that everyone agree on what each protocol does, so that people can create systems and products that interoperate. This is where standards come into play. Internet standards are developed by the Internet Engineering Task Force, and other bodies also specify standards for network components like the IEEE Standards Committee. We can also describe the Internet from a different angle, namely as an infrastructure that provides services to applications. So let's draw open a simple analogy. Suppose Alice wants to send a letter to Bob using the postal service. Of course, Alice can't just write the letter and drop it out her window. Instead, postal service requires that Alice put the letter in an envelope, write Bob's full name and address, put a stamp on it, and finally drop the envelope into an official postal mailbox. Thus, the postal service has its own interface or set of rules that Alice must follow to have the postal service deliver her letter to Bob. In a similar manner, the Internet has a socket interface that must be followed to see the data delivered to the program that will receive it. Now that we've got a bit of what the Internet is, let's consider another important word in computer networking, a protocol. So what is a protocol? Again, let's consider some human analogies and what we do when we want to ask someone for the time of the day. A human protocol dictates that one first offer a greeting to initiate communication with someone else. The typical response to a hi is a returned hi message. And then the first person asks for time, and gets the answer. Clearly, transmitted and received messages and actions taken play a key role in a human protocol. If we run different protocols, the protocols do not interpret, and no useful work can be accomplished. The same is true in networking. For example, when you make a request to a web server to have a web page into your web browser, the computer will send a connection request to a web server. The web server will return a connection replay message. Knowing that it is okay to request the web document, the computer sends the name of the web page it wants to fetch in a GET message. Finally, the web server returns the web page to your computer. So, given the human and networking messages and the actions taken when these messages are sent and received are the key defining elements of what a protocol is. Let's now take a closer look at the Internet structure. The computers and other devices connected to the Internet are often referred to as end systems because they sit at the edge of the Internet. So end systems include desktop computers, servers, mobile devices, and many other things. They are also referred to as hosts because they host or they run application programs such as web browser and web server programs or an email client program. Next, we can consider the access network, which is the network that physically connects an end system to the first router, also known as the edge router. Many technologies exist, for example, hybrid fiber coaxial, which uses a combination of fiber cable and coaxial cable as physical media, DSL and Ethernet that use copper wire, and mobile access network that use radio spectrum. Hosts connect to Internet via ISPs. These ISPs must be interconnected so that any two hosts on the Internet can send packets to each other. This interconnection creates the core network. Over the years, this core network has evolved into a very complex structure. We will talk about core network in another lecture. That is, guys, hope you have a clear idea about what the Internet is, and see you in another video.